Soccer!
Newton's first law. Newton's first law is an object in motion will stay in motion until acted upon by an outside unbalanced force, and an object at rest will stay at rest until acted upon by an outside unbalanced force. Christina Mackenzie is an example of Newton's first law because the ball is in motion until it is acted upon by an outside unbalanced force of Mackenzie, which stops the ball, and the ball is at rest until it is acted upon by the outside unbalanced force of Christina kicking the ball, which puts it into motion.
Inertia is an object's resistance to a change in its motion. Christina has less mass, so it's easier for Mackenzie to get the ball from Christina. And since Mackenzie has more mass, it's harder for Christina to get the ball from Mackenzie. Mass is measured in kilograms, and weight is a force measured in newtons.
Newton's second law states that force and acceleration are directly proportional, and mass and acceleration are inversely proportional. For example, in soccer, like what Christina and Kilty are doing right now, when a person, let's say Christina, hits the ball very lightly, her force is going to be less, so the acceleration is going to be less. And then when Christina hits it very hard, the acceleration is going to be more and the force is going to be more. And this is the free body diagram of the ball. The ball weighs 5 newtons, and that is the gravity from the earth, and then the normal from the ground. And when Christina, she is the applied force, the woman is hits the ball with 30 newtons, the friction is from the ground is 10 newtons. Liquid accelerometers, speeding up to the left. You know it's speeding up to the left because there is an arrow drawn to the left. That's when Christina kicks the ball. And this is slowing down to the left. This is when Kilty slows down the ball and stops it. The water would shoot away from, like towards Kilty, away from the ball. And this is constant velocity. In soccer, when the ball is traveling across the field, it will reach a constant velocity and it will not be accelerating. That's why there is a straight line. F naught equals m times a is another way to describe Newton's second law. In soccer, a soccer ball with more mass will have a lesser acceleration, and a soccer ball with less mass will have a greater acceleration because of inversely proportional. And since they balance out, their forces will still both be the same for these two equations. And force is a push or a pull, and force's unit is Newton. The greater the force Mackenzie exerts onto the soccer ball, the greater the acceleration the soccer ball will have, because force and acceleration are directly proportional, meaning the greater the force, the greater the acceleration. And since mass and acceleration are inversely proportional, the greater the mass the soccer ball has, the less acceleration it will have. And if the soccer ball has less mass, the acceleration will be greater. Newton's third law states that the force exerted from object A onto B is the same as the force exerted from object B onto A. In soccer, when people head the ball, like Mackenzie is doing now, the action force would be Mackenzie hitting the ball with her head, and the reaction force would be the ball hitting Mackenzie's head. Christina creates friction between herself and the ground by using cleats that they use in soccer. Because the cleats, let me see them, Christina. That was a fail. Alright, yeah. They have stubs on the bottom of them instead of actually just having a flat bottom, because then they dig into the ground better and It makes it easier for soccer players to run.
Coefficient of friction, or mu.
Center of mass is the balancing point of an object. For example, on Christina, it would be located below her belly button. And on the ball, it is located above Christina's finger because she can support it and balance it there. The ball isn't always located where there is material, and it's always below or above the support. In soccer, goalies are positioned really low to the ground, so they are more stable when the ball comes to them. Torque has to be even on both sides, and if not, the object will be unbalanced. In the previous clip, Christina was thrown off balance because Mackenzie hit her and she had more torque on the one side. And in soccer, the opposite team wants to do this a lot to the goalie so they can score goals. This is the equation for torque.
Newton's third law states that the force from object A onto B is the same force exerted from object B onto A.